Hello maths and physics lovers, welcome to Serica's Math Made Simple. Today we are going to be focusing on proving the kinetic energy formula. Now in science we all know the formula for calculating the kinetic energy of an object is given by Ka equals mv squared, where m represents the mass of the object and v represents the velocity of the object, the moving object. Okay, now because kinetic energy is an energy that an object possesses or has because it is moving. Okay, so we cannot talk about kinetic energy if an object is at rest, because when an object is at rest, at a state of rest, it also possesses or has an energy with which it rests, and that energy is called PE, that is the potential energy. But today's lesson focuses on kinetic energy. So by the end of this video, you will know why the formula for calculating the kinetic energy is given by ½mv². So let's get into it. Now to begin with, we'll start with, we know the work done on an object is given by work done. Formula for calculating the work done of an object is given by work done W is given by force times distance. Now, kinetic energy comes from work done. When work is done on an object, it produces kinetic energy. Okay, now let's call this equation 1. So I'm just going to erase it and write it properly, and then we'll call it equation 1. So W is the work done is equals to force. We put dot means times. Okay, this is equation 1. So W equals force dot Z, force times distance. Okay, and that is the expression for work done. Now let us recall Newton's second law of motion, which states that a force which is given by a force of an object, which is equals to the mass multiplied by the acceleration that the force causes the object to undergo, right? All right, so this is equation 2. Let's call that equation 2. So now F is expressed as ma according to equation 2. So if we substitute F equals ma in equation 1, F equals Fd, W equals Fd, we are going to have, this will give us W equals MAD. Okay, and let's call this equation 3. So if we substitute F equals MA in equation 1, W equals Fd, so MA replaces F, and we have now W being expressed as MAD. Okay, so we'll call that equation 3. Now, from kinematics, one of the equations of motion is written or is given by V squared expressed by U squared plus 2AS, where V squared, V is the final velocity of the object, U is the initial velocity of the object, A is the acceleration of the object, and S is the distance the object covers. Now in this case, U, now considering that the object starts from rest, so the initial velocity is equals to 0. So U is equals to 0, and if U is equals to 0, the equation reduces to V squared. The equation reduces to V squared equals 2AS. Okay, so if we make S the subject of formula, we'll divide both sides by 2A. So 2A cancels here, and we have that S is equals to V squared on 2A. Now, substituting S equals this on equation 3. Remember, equation 3 is W equals to MAD. D represents distance, and S here represents distance. So if we substitute S or D for S, equation 3 now becomes, if we substitute S for D, equation 3 now work done becomes W becomes MAD. Now since D represents distance and S is distance, we can just put this as V squared on 2A, like this. Now so A can cancel here and can also cancel here, and if that happens, we are left with W equals to MV squared on 2, and that's it. That's how we can have, remember, kinetic energy comes from work done, so W is equals to MV squared. So KE equals half mv squared. Now, so this is how the formula for the kinetic energy can be derived. If you found this video helpful, make sure you like, you comment, share it with those of your friends who also want to understand formulas proven through a step-by-step approach like this, and see you in our next lesson. Thank you.